Today's lesson is about significant figures and measurements. Now, significant figures is probably my favorite thing because it's something that I teach in the beginning of the year and it does not go away. I test you on significant figures up until the last day of school. Okay, so you need to really make sure that you understand what's going on with significant figures. Significant figures, or shortened sig figs, or SF sometimes when I write. Okay, now let's kind of talk about what a significant figure is before we actually dive into how to calculate that or how to measure them. Okay, now this lesson is just specifically about how do I figure out what is significant and what is not significant. Okay, so significant figures. In chemistry, we have to deal with significant figures because sometimes we have error because of some things. Okay, we can only be as significant or as precise as the instrument or tool that we are using in a lab setting. Okay, so let's just kind of look through this really quick. Significant figures and measurements. What is it? Measurements must always be reported to the correct number of significant figures because calculated answers often depend on the number of significant figures and the values used in calculations. Okay, so for instance, if I'm using a measuring tool like a thermometer and it has a different amount of significant figures than my scale, I need to make sure that I'm recording the right amount of numbers because the answer can only be as precise as the most precise tool. Okay, and we use significant figures based off of error or sources of error. Okay, now you've probably in the past I've talked about error in your science classes, and most of the time you've probably said, okay, something went wrong in this lab, so my source of error is human error, meaning you messed something up. Okay, I'm going to tell you right now, human error is not acceptable to write in your lab notebook. Okay, what kind of human error? Just to say that you messed something up is not good enough. You need to tell me, well, what did you mess up? Okay, so sources of error could be measuring device, so your thermometer could be calibrated wrong. Skill of a person, so that's where your human error might come into play. Can you not read things precisely? Did you not pour the right amount of stuff? Okay, so that's where your human error or the skill of the person comes into play. Did you round off the corners? Did you have a wrong angle of reading? Where did you measure? Did you put the thermometer on top of the hot plate? Or did you hold the thermometer in the middle of the water to get a better reading? Okay, so these are all types of things that you need to take into account, and this is why significant figures are important. Okay, all right, so what are significant figures? Significant figures are numbers that mean something to us, okay? Meaning they contribute to the value that I recorded in the lab, okay? All right, so let's talk about some rules for significant figures, okay? Any number has an infinite significant figures. This would be if I was saying like 2 or times 2 when I'm doubling something. Why does it have an infinite amount of significant figures? Because if I write 2.0000 and I keep going, okay, those zeros can go on and on forever. Okay, so anytime I'm like doubling a measurement, so say I need 5 grams times 2, that 2 will have an infinite amount of significant figures. Okay, a definition also has an infinite amount of significant figures. Meaning, if I say something like, there are 3 feet in a yard, okay, those 3 feet will be like 3.00000000 and on and on and on, like in my previous example, okay? Another example of this would be something like if I say there's 12 inches in 1 foot, okay? Those 12 inches have an infinite amount of significant figures. So any time that there's a definition of something, it'll be infinite amount of significant figures. Measurements or significant figures are mainly used in science classes, okay? All right, so this is kind of where it boils down to how do I know whether something's significant and whether something is not significant. Any non-zero is always significant, okay? So anything from 1 to 9 will be significant. 1, significant, 2, significant, etc. It could not be a digit, meaning it can't take up on the number line, if it wasn't measured. So like meaning, if I didn't see a 9 on the scale, that means it's not significant. Since I saw a 9, that means it's significant, okay? Zeros are where it becomes a little bit tricky. So we need to talk about some zero rules to see whether things are significant or not. Okay, we ready for this? Okay. So all zeros between two non-zeros will be significant. Okay, so let's look at my example here. 508 meters. Okay, 5 is significant and 8 is significant. Why? Because I had to read them somewhere. Okay, so since that 0, or this guy in the middle, is sandwiched between two significant figures, that makes that 0 significant. So in this number, 508 meters, there will be 3 significant figures, or 3 numbers that mean something. 5, 0, and 8, okay? So this number right here has 3 significant figures, or SF, okay? It's the first zero rule. Number 2, zeros at the end of a large number but before an understood decimal are not going to be significant. Meaning, 23,000, and then these 30 grams, these 3 zeros will not be significant. Why? Because if I was to change this into scientific notation, remember that? I'd go 1, 2, 3, 4. This would just be 2.3 times 10 to the 4th. Do you see any zeros? Do they mean anything? No. So since those zeros got dropped off when I turned it into scientific notation, that means that this 2 and that 3 are the only things that are significant. So this value right here has 2 significant figures. Okay, that's the second zero rule. Third zero rule. A 0 written before the decimal is not significant. Now this one's kind of easy because you can kind of think of it like this. 0.5. 0.5. Did the number change? No. It's the same value. So that 0 in front of the 0.5 holds no significance to the measurement. Okay? So how many sig figs does 0.5 have? Hopefully you said 1 sig fig. Okay? Fourth zero rule. Zeros after the decimal, but before the first non-zero are not significant. And this is for the same reason that zeros in a big number are not significant. If I was to look at 0.0045 liters, I could turn that into scientific notation and drop off those zeros. So watch. I'd go 1, 2, 3. So this number would be 4.5 times 10 to the negative third, because it's a small number. And since those zeros are no longer there, this value will only have 2 significant figures. Okay, so 2 sig figs here on that number. The 4 and the 5. Okay, so zeros after the decimal, but before the first non-zero are not significant. Okay, last zero rule. Zeros after the decimal and after a non-zero digit are also significant. Okay, so for instance, if I was to turn this into scientific notation like the one I did previously, so say I was to do this, 1, 2, 3. I can't move the decimal anymore. Why? Because if you remember with scientific notation, the number has to be between 1 and 9.99. Since those zeros are a part of the number, I have to write the scientific notation like this. 10 to the negative 3. I'm sorry, let me move this over here. So since those zeros still have to be written, they're considered significant. But the zeros in front were lost, so they're not significant, okay? So that means that this number right here has 4 significant figures. Okay, I know that I'm running a little long on this video, so let's do some examples, and we'll do more of these in class when you get in here tomorrow, okay? All right, so what rule is number 1 talking about? Hopefully you said rule number 2, okay? So rule number 2 says numbers after in a large number, but before a known decimal are not significant, okay? Meaning 1, 2, 3 zeros are not significant. So this value will only have 2 sig figs. Okay, what rule is number 2? Number 2 is rule number 4. Zeros after a decimal before a non-zero are not significant, okay? So this would be 1, 2, 3 sig figs. All right, what about number 3? This isn't a zero rule. By definition, 12 inches and 1 foot will have an infinite amount of significant figures because of all those zeros after the decimal. Okay? What is rule number 4? Number 4 is rule number 5. Zeros after a known significant after a decimal are significant. So this would be 1, 2, 3, 4 sig figs. What rule is number 5? It's rule number 1. This 0 is squeezed between 2 sig figs. So this would be 1, 2, 3 significant figures. And then the last one, what rule is it? It's rule number 3. A 0 before a decimal means nothing. It's just a placeholder. So this would be 3 significant figures. Okay? We're going to talk a little bit more about these in class. I just wanted you to get the main rules down, and we will discuss these. So if you have any questions, make sure you jot them down so I can answer. Thanks.